we're going to talk a little bit about spatial data. So every presentation has a who am I. I spent a lot of my time doing performance tuning, and this presentation isn't about performance tuning, it's about spatial data. So when I talk about performance tuning, I generally like to think I know what I'm talking about. But when we're going to talk about spatial data, I'm definitely outside my comfort zone. To be fair, I may only know enough to be dangerous. So this is some stuff that came after a little sort of lockdown project of my own. I decided it was time I knew a little more about spatial data. And I set off and started reading things and started Googling and messing around with some GPS data. And this presentation came out of it. I guess the other point to make is that if you ever want to give a presentation to a conference, don't worry about not actually being an expert in the subject. You just have to have a story to tell. And so this is a story of me trying to use some spatial data to solve a personal question, really. So what is the background? Well, when I'm not messing with Oracle databases, I'm a keen cyclist. And I've ridden with a club for many years, and we used to go around the countryside and we would navigate with a paper map. And you would have to stop and change the map and refold the map, and maybe you wouldn't know where you were and you'd have to work out where you were on the map. So it's a very different dynamic to sort of the modern electronic world. For younger viewers, these are paper maps. These are UK maps. Most of them there were produced by our government office that produces maps, the Ordnance Survey. I have a large, off to my right, bookshelf full of maps. That's the UK shelf. There's a European shelf below. I barely look at them anymore because we've all started using GPS. So when you take one of those maps out and you unfold it, which I'm not going to do on camera because I don't think you'll get the full effect, you get a big piece of paper. That's about, well, the area of the map is 40 kilometers square there. It's 50,000 scale, so that's an 80 centimeter square area of mapping. And that's what we used to use to navigate out on the bikes. But we don't do that really anymore. It's all gone electronic. So in the early 2000s, I got hold, this was my first ever GPS. I got hold of this in around about 2003. It's one of the early PDAs, a compact iPac, and you put it in a jacket, and you put a GPS card into the jacket, and there was some software, and you could navigate on it. And that picture on the left was taken in around 2008, so we were still using maps 5 years later. And I think I'm there on the right, and I'm holding my GPS, trying to work out where we are, and I marry that up with a map. So at the time, I had the OS maps on the PDA. Today, I go out with my cycling club. We will publish the routes in advance, and people will download them and put them on their Garmins and stuff, or they'll have the phone on the handlebars. So the technology has moved on a long way. Now I can search for routes with the structured data. So if I want to find rides that started, well, like that one, started from Shenfield, I can put Shenfield into the search engine and I'll get rides from Shenfield. If I want rides that go to a place on that route, unless that's mentioned in the structured text, I'm not going to be able to find it. So the spatial question I want is things like, well, I ride up Swains Lane every morning in London. Am I getting faster or slower? I can actually extract that from the data. Or I'm planning to ride this weekend. I want to see previous routes in a place. Find me a ride in the Chiltern Hills. Find me routes that go to Blackmore, a place. And I want to be able to put a place name in and get the routes out. That's a spatial search. And how I got to be able to answer that question, that's what this presentation is about. And it required a blend of technologies quite a few non-spatial things had to be done as well as spatial things. What is a spatial geometry? Well, a GPS track is an example of a spatial geometry. It's a list of points of where I was at a particular time. And the geometries can be a point, they can be a line, they can be an area. There are some three-dimensional geometries that are possible as well. I'm not going to get into three-dimensional. And they're defined, but the two-dimensional, the one and two-dimensional geometries, they're defined in terms of a series of points. So my first challenge is to obtain, load, and parse the GPX files which are produced by my GPS. So GPX stands for Global Positioning Exchange Format. I'm going to need definitions of places which I can search by. So Blackmore, there is a parish of Blackmore, and it has a particular area, so I can get hold of that data, or I can get the county of Essex where Blackmore is located. Or if I'm interested in the Chiltern Hills, there is a definition of the Chiltern Hills area of outstanding natural beauty. It's a official government designation, and there is a defined area for it, and the government published that data. And so most of these areas are either political or administrative boundaries, and the respective countries of the world publish this data. Most of it's publicly available, some of it requires commercial licensing, and most of it's made available in a sort of generally accepted industry standard format. And to answer that first question, you know, am I going up Swains Lane faster in the morning? I'll need a definition of Swains Lane, and I'll have to do that myself manually. And I'll show you all of that. So the spatial bit of this is, where does a track or route intersect with an area? And more generically, it comes down to, does one spatial geometry relate to another? Does it intersect? Does it touch? Does it overlap? Or is it distinct? And there are spatial functions made available by Oracle which compare spatial geometries and give you that answer. So ever since I've had a GPS on my bike, I've built up a collection of tracks. These are just the ones from my Sunday rides in the southeast of England. There today, you know, your phone has a GPS in it, and there are just lots and lots of apps out there to do navigation, mapping, and to collect this stuff. I like Strava. It's a good way of logging all of these GPS tracks and collecting a bit of structured data around them, as well as being a sort of Facebook for cyclists and now other athletes. But the nice thing is Strava will let you download all your data in a single archive. And that's the archive I've taken, and I've loaded it into a database, and I'll show you how. So the first job with any of this spatial work is to say, well, I'm going to take my GPX data from my GPS, and I'm going to put this in a database. So I've started with this Strava bulk export. All that structured data, which I typed in from the rides over the years, and I loaded my back catalog of rides from GPX files I had. That's all listed in an activities file, which is a comma separated variable file. And then for each GPS I've got, it's either a GPX file or it might be a zipped GPX file. And some applications produce what's called a fit file. So Wahoo and Garmin produce fit files. If you're playing with a virtual trainer, they produce fit files. That's a binary thing. I haven't tried to load that directly. I just convert it to being a GPX. And most spatial GPS data comes out as GPX. So very simply, I'm going to unzip all of my files and put them on a directory on my database server. I'm using a little virtual machine. There's a little demo coming later. The fit files I've just converted with GPS Babel, and I did that on my desktop. And I'm going to create a schema where I'm going to put all my data. And the only thing I really need to give this user is I'm going to grant it XDB admin so that it can define its own XML schemas, because I'm going to need to define the XML schema that defines the GPX objects so I can read it back. And I've created some directories where I've got my files. You'll notice I've also got an execute a directory called exec.dir, which is user bin, and I'm going to grant execute on that. The reason is that enables me to unzip a GPX file on the fly and read the zipped file in as an external table. And I've got a couple of other things I need to be able to execute as well. So I've got execute privilege on my Strava directory too. So my Strava directory is where my GPX files are, and generally I only need read access on that. One of the things I discovered is that if in a CSV file a string has a new line character, when you try and do the external table load treats that as an end of file. So I have had to convert to strip out those end of line characters. And I've written a little shell preprocessor which does a gawk on the line, and I call that as a part of the load. And that means I don't actually have to edit the CSV file. I can just do the conversion on the fly. Just an interesting Ask Tom question where I got the answer for this from. And this little script, nlfix, does it for me so that I don't have to edit the Strava CSV file. Useful little trick. And then all I do is I create an external table to map to my CSV file. And you'll see here I've specified preprocessor nlfix. So it preprocesses the file, types it through nlfix and reads it in. All of the work I've done has gone into a PL SQL package, and I can either unzip the file and read it in as a blob or read it in directly. So now I've got my GPX file from an external file into a CLOB column, well, an XML column, which is GPX. And so I just work through all of my activities. Where I have got GPX files, I actually zipped them again. So I changed the file name. And now I just read my activities into my Strava table. So I now have a table with my activities. Each of my Strava activities is a row in my table. Each one now contains the GPX file in a CLOB. The next stage is I need to read my GPX file, which is an XML structure. So that's a GPX file is emitted by GPS, and it's got a list of points in it. GPX is just a form of XML. It's not really different to any other XML you might come across. It's got a particular structure. Those structures are defined by published schemas. And it's useful to have those schemas available to you. And there's also some extensions. So there's the basic format. You have a track point, and it's got a time. It has, in this case, it has an elevation, and it has a latitude and longitude. You'll see also there's some Garmin extensions, and there's some extra data which you can put in your GPX file. And again, it's defined in an extension to the schema. And in this case, for instance, if you had a heart rate monitor or some other piece of information about the metrics being collected with respect to position, they're embedded in the XML file. And I'm going to read them back in a little while. So I need to register these XML schema definitions. So with GPX, there's a 2002 version, and then it was upgraded in 2004. In fact, it's been very stable. No one's ever since. No one's changed it. Garmin have created an extension, and they store things like the athlete's heart rate, cadence, how fast the pedals are going round, and external temperature. And there is another extensible part of that, which is you can put any other piece of information in, and to allow people to continue to put extra data in. And certainly now you see lots and lots of athlete analytic utilities which take this data and work with it. But so I'm going to download these XSD files. That's where the schema definitions are, and I'm going to load them up as an XML document, and then I'm going to create the schema in Oracle. So having done that, I can read the GPX file, and I can just extract the table as an XML sequence, and now each data point in my track that you saw earlier becomes a row in a query, and I can pull out each of those pieces of information in my GPX file. So I get a timestamp, I get the latitude, the longitude, I read the elevation from the GPX data, and I've got a heart rate there coming in from that Garmin part of the schema. And they just now it's just a row set. It's like any other query. And I've got data that I can work in like any other query. Now, when you're dealing with GPS data, you have to have an eye, or spatial data, I should say, you have to have an eye to what coordinate system there is. And there is a public registry of coordinates called the ESPG registry. So ESPG stands for the European Petroleum Survey Group. And these were the guys who first started to do this, but define these spatial forms and define the coordinates. And there are thousands of coordinate systems out there. And a lot of them are available in Oracle. So if you go to Oracle 19, you can actually query them back from SDO coord refsys, and you'll find over 6,000 just in Oracle. Some of them look very similar. You know, there's lots and lots which are latitude, longitude, and what the difference is actually is the geoid. So it's how you calculate altitude above mean sea level. There is a sort of global geoid, but some countries have their own country-specific geoid because it's more accurate for that little area of the country. So I'm going to be interested in two coordinate systems. There's 4326, which is otherwise known generically as the World Geodetic System 1984, because that was the year it was adopted. And that's the data that comes out of most GPSs. That is almost the default coordinate system that people use when you're specifying latitude, longitude, and elevation. It's probably come off a GPS. It's probably WGS84. In the UK, all of the Ordnance Survey data uses the Ordnance Survey coordinate system, which is, meters east and north. It's known as OSGB 1936. It's based on the Aries spheroid. It was adopted by the Ordnance Survey in 1936, and it was baselined in 1936, and it's known as 27700. And you'll find that most of the British information from the UK government and the Ordnance Survey and the Scottish Spatial Hub, that's all in OSGB. And you need to just have an eye to where the data is coming from and what the coordinate system is when you store this stuff. Otherwise, you run yourself into a few problems. So for instance, you have to compare geometries of the same coordinate system. You can't compare geometries of different coordinate systems. And you can also see there that the WGS84 coordinate system, it's got some extra information to say, well, the coordinates are bounded to, well, latitude plus minus 90 and longitude plus minus 180. Whereas there's no such bound on the British National Grid because it's just a Cartesian coordinate. So they don't cap it. One of the things I found it was useful to do was to create a little PL/SQL package function, which will convert a latitude and longitude into a spatial point. And the reason is that if I'm going to process some of the non-spatial attributes in my GPX file, I'm going to need to work with the latitude, longitude, and only convert it to a point later on. So this was a really useful shorthand I found. And you can see all I'm doing is I say, well, create a geometry. 2001, well, the 1 means it's a one-dimensional geometry because it's a point. It's 4326 because it's GPS data. It's WGS84. And then simply, it's a spatial point. and it's latitude, longitude, and the third one is null because I'm not putting in an elevation. And now that returns me a spatial point, and I'll use that a bit later on. So I'm going to extract my points from the table and append them into a track points table, for instance. And you see at the very end there, I'm taking my latitude and longitude, I'm pushing it into the make point function, and now I get a column on my table log, which has got the location in it, and that's a spatial location. Today, there are, as you've seen, there are two GPX namespaces for the different versions of the schema. And you just have to have an eye to which version your GPX is in. So some of my older GPX files are 1.0, and most of the modern devices produce 1.1. Those fit files that I converted back to GPX, for some reason, they come out in GPX 1.0. So before you go reading it, you have to have an eye to it. So when I look in my GPX file, I extract the name of the namespace, and I store that in the database as well. And I do that while I'm updating the GPX with a returning clause. So I've got this package function which does a number of updates as I load it. I'm going to take those points in my XML, and I'm going to convert them into a spatial geometry. So this part of the query is simply going to extract the points. Each point is a row with a latitude and a longitude. This is just a dummy inline view that returns two rows. Two rows because there are two coordinates, x and y, longitude, latitude. I tried using connect by prior where level less than 2. I ran into a problem with it. It generated an error in this context. That's why I'm using this union all. And now I'm simply going to order those rows by the point number. So in order which the points are on my GPX. And I'm going to produce a row 1 and 2 for each one. And then if n is 1, then it's longitude, and if n is 2, it's latitude. So my rows are going to be first longitude, first latitude, second longitude, second latitude, etc. I'm going to turn that into a multiset. That basically turns my list of rows into a list of numbers. And that's all the spatial geometry is. It's a list of numbers. And my list is going to go longitude, latitude, longitude, latitude. And that's all the spatial geometry is. It's a list of longitudes and latitudes. Then I'm going to cast that to a spatial ordinate array. And now I can turn that into a spatial geometry, and I can write it to my geometry column in the table. And while I do that, by the way, I'll also specify what the namespace is. So now I've taken my GPX and I've converted it into a spatial geometry, and I've stored it in the geometry column. If I'm going to index my geometries, I also need to put bounds on my indexes. So there's that plus minus 90 and 180 for the WGS geometry, and I have defined minimum and maximum values for the national grid that I'm going to index, and that's in my 27700 one. And then I can create indexes on my geometries. And I've created one on my geom column, which is WGS84, and you'll see I've got another geom column, which is national grid. So at the beginning, I posed a question: am I going up Swains Lane faster or slower? So I need a definition of Swains Lane. I've drawn a route, and Swains Lane is a steep hill in North London. And there's my route. It's just a list of points again. And all I'm going to do is I'm going to load that up as a geometry, and I'll convert it in exactly the same way. Now, when I did this with routes, I had a bit of trouble with some of my route tracks drifting away too far from the route. So then I did another kind of shape. I drew a box around Swains Lane, and with just 4 points, but there are 5 points there in my geometry because I need to close the shape by making the 5th point the same as the 1st point. There's my box drawn around Swains Lane. Now all I have to do is look at the rides which went up Swains Lane. Do they relate to Swains Lane? Does my track geometry relate to my Swains Lane geometry? Here's all my activities. Now I ran into a problem. You can't pass geometries to an analytic function. So I'm going to have to do my analytics and then convert it to a point. When I write this kind of query, I use a series of common table expressions for with clause subqueries. And I pipeline the data from one to another. So this one is extracting the points for the geometry. And then I'm going to, well, altitude data is notoriously noisy in GPS, so I'm going to smooth it over 5 points. And then I'm going to get the current point and the last point as different sets of columns. But notice I'm pulling the current latitude, longitude, and the previous latitude, longitude. It's not spatial yet. And then I'm going to convert those latitude and longitudes to points. And then I can do things like, is the point inside close enough to the Swains Lane geometry? What is the distance between this point and the last point in meters? So there you can see the SDO distance function provided to us by Oracle. Now this route goes up Swains Lane 3 times. So some points will be in the Swains Lane geometry and some will not. Every time that changes, I'm going to count 1. Then I'm going to keep a running count of the geometries in Swains Lane. So I can now split out my 1st, 2nd, and 3rd ascent to Swains Lane for each activity. And now I can do some reporting, classical stuff. So min, max time, sum, max speed, average speed, that kind of thing. So you can see there are 3 ascents. It's about 300 odd meters long. It takes me about 2.5 minutes. Sometimes I'm faster, sometimes I'm slower. So I've done some analytics on some spatial data, which on my XML data, and some of that data has been produced with analytic calculations. Now, this turned out to be really CPU intensive, and in fact, it was actually the analytics that took longer than the spatial stuff, and I wanted to process all the data over quite a long time and graph it because I wanted to know, am I getting faster or slower? And when I did this back in February, it said I'm getting slower. So recently I did it again and I split it out per bike, and I've got one bike which I'm noticeably slower on, and you can see it changes color again over here. So my new bike is no faster than my old bike, but it's early days. So bit of fun. Did some analysis on some XML, did some spatial work as well. Oh, and subsetted those GPX files using a spatial analysis. Which brings me on to the wider questions of comparing geometries. Some of them get quite big, and they can be slower to process. So I tend to simplify them down, which is just depopulate excessive points. Because I've got some data in WGS and some in UK format, I've actually you can't compare different formats, but you can convert them. So I have Oracle do the transformation from WGS 84 to OSGB, and I store both of those in the database. I also keep a count of the number of vertices just to see how complex the environment was. That was more for looking at the performance of this than any practical benefit. When you compare them, one technique to improve the comparison is minimum bounded rectangle. So here's a route. That's a real route, so you can see how many points are in a real route. And there's an area, and that's a real area. That's the outline of Greater London. So is this route in that area? So it's really easy for us to look at it and say, well, no, it isn't. But for Oracle, it's got to compare everything. Draw a box around the route and a box around the rectangle. If the 2 boxes do not impinge, then the route is definitely not in the area. What about now? Well, now the route is in the area and the boxes definitely overlap. And now? Well, the boxes overlap, but the route isn't in the area. So use minimum bounded rectangle to eliminate routes that you know cannot possibly be in an area, or two areas that definitely can't overlap. But be aware you're going to get some false positives like this. So only if minimum bounded rectangle matches do you go on to do a proper comparison of the area. So I found this was a sort of optimization technique. So this is about performance after all. And also I just calculate the minimum bounded rectangle as a geometry. I store it in the database, so it's a one-time, and it's really quick, and it just resolves that big area down to 5 points. So back to that other question. I'm looking for rides in the Chilterns this Sunday. So where did my previous rides go to the Chilterns? So I've taken my working definition of the Chilterns from these political boundaries. Now the world's divided into lots of countries. There are 206 areas, including independent and leased areas. Different countries split themselves down differently. You know, France, I think, is the one with the greatest number of subdivisions. They go down 5 levels. UK, we're a bit of a mess, to be honest. We've got 4 countries, and the countries are broken up differently and administered differently. And then we've got the Channel Islands and the other Crown dependencies, and then we've got a bunch of other areas which are sort of left over. And they're all defined as areas. Within UK, or within Great Britain, really, you've got the Ordnance Survey provides all the lines. Scottish Government has its own spatial area. Chilterns is an area of outstanding natural beauty defined by the Department of Environment, Fisheries and Rural Affairs. And you can download all this data, and it comes out in what's called an ESRI shapefile. And that's got, that's a zip archive. It has a shapefile, which is the geometry. It has a DBF file, which is the database, the information you're going to load. And you also get the projection sometimes and the code page. And Oracle provides this Java utility to load those ESRI files up into spatial geometries in a table. Now, you can make this do a conversion from one to another. So I could have converted the UK OSGB to WGS, but it slows it down a lot. So I let it just load it in the base geometry and then convert it later. I find that faster. And I've written load scripts. So I treat that table that's loaded by the shapefile loader as a staging table, and I load them on into a consolidated table, which I'm going to search. I tidy up the names a little bit too. And then I work out a hierarchy of areas. Now, some of this ESRI data has the hierarchy in, some of the UK stuff, I've had to work it out because they don't say exactly which wards are in which unitary authority. So I've had to do some calculation. But ultimately I create a hierarchy, and then I can search by going down the hierarchy. So is this line in a country? Is it in a county? Is it in a borough? And that hierarchical approach means that I don't just search every area for every route, and it cuts down the amount of time. Even so, it's too slow for an online tool. You know, I've got 62,000 areas loaded. France is 40,000, the UK is 2,000. By comparison, the Netherlands is only 500, and I've gone down 2 layers in Germany, and it's only 493. But my spatial data is static. The activities don't change unless I edit them for corrections, and the boundaries don't change very often. In the UK, in my life, we've only had 2 major boundary changes in 72 and 92. So it's pretty static stuff. So what I do is I pre-process everything. I want every area for every activity. I ended up with 81,000 hits across 3,000 activities. And so here's the recursive search. And I start from a point or from the root, and I say, find me the areas, maybe the root areas, i.e. parent is null, or the named area. Is the root in here? If it is in here, does it have children? Oh, and there's that minimum bounded rectangle thing. Check the minimum bounded rectangle and then check the geometry properly. And then if there are children, recursively search each of the children. So this is one of these rare occasions where you can use recursion. And here you see the output of the search. This route was in the UK. Then we found it was in England. Then we found it was only in Greater London. And then within Greater London, 2 boroughs, 2 London boroughs. And then within the London boroughs, it was in these 5 wards. So these are the hits which I found, and they'll go down into the hits table. And now I don't have to calculate that in future. Having done all that, this whole problem becomes one of text searching. I now need to text search for the area and then go back through the hits table. So I have my areas and my activities, and I have the hits in activity areas. My areas are in a hierarchy, and they join back through activity areas to activities, but my text search is going to be against the area table. So I might want to search for Streatley. I used to live in Streatley in Berkshire, but there's another Streatley in Bedfordshire. Which one do I want? There are lots of Twyfords in the country. Sometimes Twyford isn't even at the beginning of the name. If I'm interested in Twyford, I need to find the Twyford in Winchester as well as the Twyford in Wokingham. And then you get other really common names. So a lot of UK names which turn up in either the US or in Canada or Australia or New Zealand. Surprise, surprise. So which country am I going to be in? Sometimes you need to specify, be more precise about which name you're specifying. And you can do that with a text index if I index the hierarchy. So I'm going to create a function to build the hierarchy. Again, it uses a connect by prior hierarchical query. And I can build an index on it. One way is to update the hierarchy onto the areas table and then just index that straight. And I have a multi-column data store where I'm going to index the name and its hierarchy. Or I could index that function directly. Pass the row ID of the row I'm indexing, and I get, through another parameter, the data I'm indexing. So my hierarchical query now builds up the index key. This time, and just to prove it's not a fake, I'm going to get the row ID of an area, and it's going to give me the hierarchy. And that's right. That was Streatley in West Berkshire in England in the United Kingdom. And here, when I build my index, I can say index this function. So in the attribute of my data store, I can index the function. I can search for Streatley, I get my 2 hits. But I'm going to search for 2 items here. This is what text searching lets me do. I can search for Streatley and Berkshire. No, it's case insensitive, and it was a substring of Berkshire. I'm going to jump this. So I'm going to eliminate the parents from my search. I'm going to say which rides went to Berkshire in this date range, and I got my list. I've got 4 activities there. I got a duplicate there because West Berkshire and Berkshire are not actually the same area. But I won't bore you with that. And just because we should have been in Nuremberg this week, but we're not, I thought I'd stick Nuremberg into the search. And I have actually cycled in Nuremberg. 3 years ago, I took the train to Nuremberg and I put a bike on the train so I could get around Nuremberg. And then just to top it off, the last thing I'm going to show you is I built a little Apex front end for this. And I've got all this data. I'm now just going to have a little Apex front end, and I hope this is going to work. So I'm going to search for, well, let's search for Nuremberg again. I didn't find it. Let's search for Blackmore. Okay, so there is a ride to Blackmore, but there's no mention of Blackmore in any of the structured data. I'm going to click on that, and it will take me to the activity on Strava. So this little app has basically just become an index for Strava. And here is my Strava activity, and it will load in a second. It might, and I'll be able to show you on the map that there is Blackmore on the map, just north. There you are, Blackmore, just north of Shenfield. So get rid of that. Little trip through Spatial. We loaded the GPXs. We did some processing. We created some text indexing and created an Apex front end. And now I can search for my areas by search spatial data. Everything you've seen today, A, is in an article on my blog, and B, all of my files are out on GitHub. I kind of hope this has been useful. Please feel free to contact me. The URL is at the bottom of the slide. Thank you.